everyone, it's Kirk, and today I want to show you Mandate, a project I've been working on to make financial AI agents safer. Mandate started after I saw an AI agent, which is Grok, got manipulated through prompt injection and moved crypto from an automated wallet. The transaction itself was technically valid, but it was not what the user intended. So that made the problem very clear to me. As an AI agent gain access to wallets, the model cannot be the final authority over our assets. So this is the Mandate. Mandate is not a new blockchain, and it is not trying to replace existing wallets, agents, or payment networks. It is a policy enforcement and verification layer that sits between an AI agent and financial infrastructure it uses. Before an AI agent can trade, send money, or interact with a wallet, the user defines a mandate. A mandate can include rules such as which assets the agent is allowed to use, how much it can spend, which wallet addresses it can interact with, when it is allowed to execute, and which actions require human approval. Every action proposed by the agent is checked against these rules before execution. Even if the model is manipulated, prompt injected, or simply makes a mistake, it cannot execute an action outside the authority defined by the user. The core idea behind the mandate is to separate reasoning from authorization. The goal is not to prove that AI model is trustworthy. The goal is to prove that the financial action generated by the model follows the user's rules. To test inside a real agent workflow, I integrated the Mandate SDK and MCP server with the MoonPay agents. MoonPay agent can still understand natural language commands, inspect a wallet, and prepare transactions. But before a transaction can continue, the agent uses Mandate to check whether the proposed action is authorized. This allows us to add enforceable security policies to an existing wallet agent without changing the underlying blockchain or rebuilding the agent from scratch. Here you can see the Mandate MCP server configured inside MoonPay agents. MCP allows the agent to discover the call Mandate tools directly from the same interface. Through these tools, MoonPay agent can retrieve active mandates, inspect the current protocol state, evaluate the proposed transactions, generate a compliance proof, and verify whether the action is authorized. First, I will confirm that the Mandate MCP server is connected. And as you can see, MoonPay agent can detect the Mandate MCP server. And then next, I'm going to retrieve the current Mandate approach. Proposed transaction is within allowed limits, so Mandate can generate an authorization record for it. Now I'm going to inspect that result. Successful transaction proves that the integration works. But the most important part of the Mandate is that what happens when the agent receives an instruction that violates the user's rules. Now I'm going to intentionally request a transaction above active spending limit. This MoonPay agent integration demonstrates how Mandate can be added to an existing financial agent. MoonPay agent remains responsible for understanding natural language and preparing the transaction. Mandate independently defines and enforces the boundaries of what the agent is allowed to do. Mandate acts like a portable authorization layer between the model and the execution. The same architecture can eventually be integrated with the other wallet agents, trading agents, payment applications, smart accounts, and financial infrastructure providers. Today, financial agents are becoming capable of holding wallets, trading assets, and moving money, but model-level safeguards are not enough. Mandate assumes that the model may fail. It lets users define the agent's authority in advance, enforces these limits before execution, and creates verifiable evidence that an action followed the rules. My goal is to make Mandate the authorization and trust layer for autonomous finance. Thank you for watching.